Let's consider an example. Let's assume that you want to design a runway for a small plane. You know that the plane can accelerate, the acceleration of the plane can be 2 meters per second squared. And before takeoff, you know that it has to reach a final speed of 100 kilometers per hour. So the acceleration of the plane is 2 meters per second squared. The speed for liftoff is 100 kilometers per second. And you first consider a runway that is 150 meters. So you want to know whether this 150 meters would be enough for this plane to lift off or not. So that is part A of this example. 150 meters is enough or not. And then if it is not enough, what should be the minimum distance of this runway so that such a plane can take off? Now first let's change the units of our speed. I mean, we are using the meters and seconds, not kilometers per hour. So the velocity of this plane for takeoff should be 100 times 1000 meters, that is 1 kilometer, divided by 1 hour is 3600 seconds. So the speed of this plane should be 27.8 meters per second just before the takeoff. And we know the final speed the plane should have, and we know the acceleration. So from this equation, we can use this relation. This relation should be satisfied. So let's calculate first what the speed of this plane will be at the end of 150 meter runway. So if the final speed is larger than this 27.8 meters per second, in that case we know that a 150 meter runway would be enough for such a plane to take off. So this expression for us gives us the velocity of an object which is moving at constant acceleration that starts from an initial speed of v0 with an acceleration of a after a distance x minus x0. Now this plane will start from rest, so the initial speed is 0. We know the acceleration is 2 meters per second squared, and the distance it has, this plane, is 150 meters. So if we just multiply, this is 600 meters squared per second squared. This is the speed squared. If you take the square root, the speed is 24.5 meters per second, which is the square root of this 600 meters squared per second. So we see that this plane, if it tries to take off in a runway that is 150 meters long, at the end of the runway, it will just have a speed of 24.5 meters per second, which is not enough for this plane, which needs 27.8 meters per second to lift off. Now we can ask the question, if 150 meters is not enough, how long should the runway be? Well, again, we will use this same expression. This time, what we don't know is this expression over here. We don't know the distance it needs. We know the final speed. The final speed is supposed to be 27.8 meters per second. The initial speed is 0. We know the acceleration. So there's a single unknown. And we can find that the distance, the length of the runway, which we can just call it x minus x0, should be equal to v squared. The speed it should have is 27.8 meters per second. This is the speed the plane should have at the point x. The initial speed v0 at the point x0 is 0. It starts from rest. The acceleration is 2 meters per second squared. So this distance turns out to be 193 meters. Now, of course, in this approximation, in this solution, we first made a model. We modeled the plane as a point particle. Well, that is an approximation. That won't be precise. So we can just say 193 meters is enough, but we can round this to 200 meters So a runway whose length is 200 meters, if you have a runway that has a length of 200 meters, such a plane that can accelerate at 2 meters per second squared and needs 100 kilometers per hour to lift off, such a plane can lift off in this runway.